Hello students, welcome to my class. In this video we are going to be discussing about simple pendulum and its applications. Related problems we are going to be discussing. Here the first question says, if the length of the pendulum is made 9 times and the mass of the bob is given as here 4 times it is given, then the value of time period becomes they are asking. Time period of the simple pendulum formula will be t equals to 2 pi into root over L by G. This is the initial time period you can take. Now length of the pendulum, if it becomes here 9 times of itself, mass of the pendulum it becomes as 4 times it's given to the initial mass. Here be remember students, in the formula t equals to 2 pi into root over L by G, time period of the simple pendulum does not depends on the mass of the bob. So then new time period when you are talking here t dash equals to 2 pi into, you can declare as root over L dash by G, which is nothing but 2 pi into L dash will be getting as 9L by G, you can take. Root over 9 is nothing but you can declare as 3, you can take. It's a 2 pi into, you can take as root over L by G, which is nothing but here will be taken as t dash equal to, here you can declare as 3 times of, this is the initial time period you will be getting. So the final time period will be getting as 3t will be getting. Let us see the next question. The next question says here, a simple pendulum performs a simple harmonic motion about x equal to 0 with an amplitude a and the time period is given as t is given. Now simple pendulum is performing the simple harmonic motion. This is the mean position you can take at x equal to 0. And here now it's going to be making certain oscillations, and this is the maximum amplitude you can take. This is the maximum amplitude. Here at this point here at x equal to, here we will be getting as a by 2 distance. They are asking the speed of the pendulum. Speed when you required in the sense here speed of the pendulum, which will be equal to speed at a given partner at a given position is v equal to omega into, you will be getting as square root of a square minus y square you can take, or it's a given as x is given x square you can take. Omega is nothing but here we will be getting as 2 pi by t into a square minus x is nothing but here you can get it as a square by 4 you can take. Now when you are simplifying this one, here we will be getting as 2 pi by t into, and 4a square minus a square will be 3a square. So it's nothing but root 3a by 2 will be getting. So this 2 gets cancelled, then velocity of the particle or velocity speed of the pendulum at a distance x equal to a by 2 will be getting as pi into, it's a root 3 into a by t will be getting. So this is the correct answer. Let us see the next question. The acceleration due to gravity at a place is given as pi square meter per second square is given. G value is given as pi square meter per second square it's given. Then the time period of the simple pendulum of length 1 meter is. Here length also it's given as 1 meter. This is a direct question students. So time period of the simple pendulum is t equals to 2 pi into root over L by G, which will be equivalent to 2 pi into L value is given as here 1 meter. And G value is given as pi square it's given. When square root of pi square when it comes to the outside, here we will be getting as 2 pi by root pi square, pi and square and root gets cancelled, pi you will be getting, pi gets cancelled. Then time period you will be getting as 2 seconds you are getting. Let us see the next question. The length of the second pendulum on the surface of the earth is given as 1 meter. The length of the second pendulum on the surface of the moon they are asking. And G on the moon is given as here G on moon, which will be equal to G on that surface by 6 you will be getting. Now here you can take time period of the simple pendulum formula will be t equals will be getting as 2 pi into root over L by G. Here G is going to be changing, G on right, the length of the second pendulum on the surface of the moon they are asking. Now here I just equate here, they are not talking about the time period, length alone they are talking here. When time period you are making as constant, here you can get it as L is directly proportional to G you will be getting. Then here length on moon to the length on that surface you can take, which will be equal to g on moon to the g on earth you can take. So here the length of the second pendulum on the surface of the moon they are asking. So here length of the pendulum on the moon by, which will be equal to, here you can get it as length on the earth surface, which will be equal to g on moon is nothing but ge by 6 into, will be getting as, here it will come to the denominator, ge will be getting, so ge gets cancelled. Here the length of the second pendulum on the surface, here length of the moon on the second pendulum, here it's given as length of the second pendulum on the surface of the earth is given as 1 is given, so that here will be getting as 1 by 6 meter will be getting. So second pendulum they are talking, but here a second pendulum length is given as 1 meter is given, and here we just calculate length of the pendulum on the moon, second pendulum on the moon, it will be 1 by 6 meters will be getting. Let us see the next question. A simple pendulum has a solid bob of relative density is given as 6. Relative density of the solid bob is given. Relative density in the sense density of the bob by, here density of the water you can take, here it's given as 6, which will be equal to density of the bob by density of the water will be 1 gram per cc. So then density of the bob will be getting as 6 gram per cc you are getting. Now here it is oscillating inside the non-viscous liquid of relative density 1.2. Liquid density is given as 1.2 is given. Relative density of the liquid is given. Relative density of the, this is bob you can take, and here this is bob, and the relative density of the liquid is given. Density of the liquid by density of the water you can take, that value is given as 1.2. Then density of the liquid by 1 gram per cc you can take, that doesn't mean density of the liquid value will be getting as 1.2 gram per cc will be getting. Now here a simple pendulum is going to be oscillating inside the liquid. Here liquid you are taking, here inside the liquid a simple pendulum it's going to be making oscillations. It's going to be making oscillations. Now here here it will be like some kind of tensional force it will act, and along with that buoyancy force is going to be acting, and here it will be weight of the body it's going to be acting downwards. Then here T equals to when it is in outside of the liquid, time period of the simple pendulum formula will be T equals 2.2 root over L by Z. When inside the liquid you are placing the simple pendulum and you are going to be oscillating, then G will be affected. Then new G dash value here will be getting as, here there is an apparent loss of the weight formula will be getting as mg dash, which will be equal to mg into, here will be getting as 1 minus density of the liquid by density of the body. This is apparent loss of the weight formula we are learning in the fluid mechanics topics. So when you are cancelling, G dash equals to, here you can write as 2 pi into, it's a root over L by G dash in the sense G into 1 minus density of the liquid by density of the body you have to substitute. So which is nothing but, here will be getting as T dash equals to 2 pi into root over L by, this is G into, here will be getting as 1 minus liquid density we have calculated already 1.2 by, here will be getting as 6 will be getting. So when you are simplifying this one, here will be getting as, this is T dash equals to 2 pi into 6, here it will be 0.2 times, here this is 0.2 times it goes, 0.2 you can write as 1 by 5 you can write, it's 5 minus 1, here it is L by G into 1 minus 0.2 I am just writing as 1 by 5 I am writing. So 5 minus 1 is 4, 4 by 5, so together we will be getting as 2 pi into, here we will be getting as 5L by, it's a 4Z already. So this is the correct answer. Let us see the next question. The next question says here, a simple pendulum is suspended from the ceiling of the lift. Ceiling of the lift is given. When the lift is at the rest, its time period is given as T is given. With what acceleration should the lift be accelerated upwards in order to reduce its time period t by 2? So here a simple pendulum suspended from the ceiling in a lift is given initially. Here this is a lift you just imagine, and here when you are suspending freely inside the lift, when the lift is at rest, it's taking the time period will be t seconds, right? Here it's making oscillations, then the time period of the simple pendulum will be getting as 2 pi into root over L by G will be getting. Now here with what acceleration should lift to be accelerated upwards in order to reduce the time period is t by 2. Now with what acceleration if the lift is moving, so the time period can be reduced as t by 2. So here lift when it's moving upward direction, the new time period, the formula will be t dash equals to 2 pi into root over L by G dash you can take. Here in the lift cases we are learning students, G effective when it's moving in upward direction, this is L by here you are writing as G plus A you are getting. So now here this time period t dash is given as t by 2 is given, which will be equal to 2 pi into here you can take as root over L by G plus A you can take. Now here you just simplify this one. Here we need to calculate the acceleration value. So when you are simplifying this one here, this is the first equation you can take and this is the second equation you can take, and here you can take as this is like 2 by 1 if I am taking, 2 by 1 if I am taking, this is t by 2 by t you can take, which will be equal to, this is 2 pi into root over L by G plus A by here we will be getting as 2 pi into root over L by G you can take. 2 gets cancelled and here this tt gets cancelled, and here we will be getting as this is 1 by 2 which will be equal to, this is here root L also gets cancelled, here you will be getting as this is 1 by this is G plus A, and here in numerator this is root G will be getting. So you just square on both sides, here we will be getting as 1 by 4 which will be equal to G by here you can take as G plus A, then G plus A which will be equal to 4G will be getting, then A equal to will be getting as 3G will be getting. So A equal to 3G is the correct answer. Let us see the next question. The next question says a simple pendulum suspended from the ceiling of the stationary lift. So here this is a lift is given, and here a lift is initially at the stationary mode, and here you are suspending a simple pendulum. Now here it's making oscillations. The time period when it is at rest position, time period will be getting as t dash t naught is given, which is nothing but 2 pi into root over L by G will be getting. When the lift descends at a steady speed, the speed the period is given as t1 is given. Lift is moving with the steady speed is given. With the constant speed, lift is moving down, and again it's making oscillations. Here speed you can take as constant you can take. If any body is moving the uniform velocity, here right acceleration is nothing but here will be taken as g you are taking. A effective acceleration is nothing but g will be taken. Whereas in this case also here the time period formula will be getting as 2 pi into root over L by G alone. And the third case here it's a descends with the it descends with the constant downward acceleration. The period is given as t2. Whereas in this case here it's given as here lift is moving down with the constant downward acceleration A. So means here when it's moving down with the constant acceleration, then new time period is given as t2 is given, then here G will be affected. So here it's nothing but 2 pi into will be getting as the root over L by G minus A you can take. These are the three cases we'll be getting. So here when you are comparing this one, here we'll be getting as t dash or t naught, which initial time period t naught, which will be equivalent to the t1, and this value G is going to be decreasing and time period will be less. So this value will be getting as lesser value will be getting t2 value when compared to the t1 and as well as t2 or t naught. So t naught equal to t1 will be getting these values, it will be more than t2 will be getting. So here this is a relation will be getting t naught equal to t1 less than t2. Here G value is decreasing and here effective G value is going to be decreasing here in this case. Let us see the next case. The ratio of the frequencies of the two pendulums are given as 2:3, then their lengths are in the ratio they are asking. So time period formula will be getting as 2 for the simple pendulum case is 2 pi into root over L by G, and frequency when you are talking here n equals to 1 by 2 pi into you can take as root over G by L you can take. That means here frequency how it is related to the length of the pendulum, in the sense here n is inversely proportional to L you can take. That means here frequencies ratio, their lengths ratio they are asking. So here you can take as n1 by n2 which will be equal to you can take as L2 by L1 you can take, which is under root. Then here if I am squaring on both sides, here we will be getting as this is here I am just reversing this one, these two things. Here L1 by L2 when I am talking here you can take as this is n2 square by n1 square you can take, which is nothing but ratios is given as 2:3. So this is n1 is to n2 is given. So here n2 is to n1 in the sense here you can take as 3 square by 2 square you can take, which is nothing but 9:4 will be getting. This is the correct answer. Let us see the next question. The next question says a simple pendulum with a metallic bob has a time period is given as t. The bob is now immersed in a non-viscous liquid and oscillated. If the density of the liquid is given as 1/4 that of the metal, then the time period of the simple pendulum they are asking. So in the here initially metallic bob is given, and here it's going to be performing simple harmonic oscillations, and this time period will be getting as in the air medium 2 pi into you can take as root over L by G you can take. Now the same bob if you are placing in the non-viscous liquid, so it's a placing in the non-viscous liquid it's given. Now you are allowing to oscillate. This is a non-viscous liquid you can take. Now the new time period value here inside the liquid, in the sense 2 pi into you can take as root over L by G will be affected. That is nothing but G into you can write as 1 minus density of the liquid by density of the body you can take. So here it's given as T dash which will be equal to 2 pi into this is root over L by G into the thing is given as density of the liquid is 1 by 4th of density of the body is given. So here G into here you can take as 1 minus here it is 1 by 4 of this is 1 by 4 of density of the body by density of the body will be getting, and here density of the body gets cancelled. Here we will be getting as 4 minus 1 is 3 by 4 will be getting. This is 2 pi into root over L by G into here will be getting as 3 by 4. When it 4 comes to the numerator, here will become as root 4. Root 4 when it you can take outside, then T dash equals will be getting as 2 into 2 pi into root over L by 3 you will be getting. So here it's nothing but here 2 by root 3 you will be getting outside, and rest will be 2 pi into root over L by G you will be getting. It's nothing but 2 by root 3 into you can take as T. So this is the initial time period you can take as T is given already. Instead of this one you can take. So it is nothing but 2 by root 3 into T will be the answer. Let us see the next question. A simple pendulum of length is given as L and has a brass bob attached at its lower end, and its time period is given as T is given. If the steel bob of same size having the density x times that of the brass replaces the brass sphere and its length is changed to, that period is given as 2t is given, then the new length they are asking. Now here initially a simple pendulum you are suspending of length is given as L is given. This is the length of the pendulum you can take from the point of suspension to the center of the bob, and at the lower end you are attaching a brass bob. This is the brass bob it's given, and here now it's going to be taking the time period will be T is given. T equals to 2 pi into root over L by G will be getting. Now here if a steel bob of same size having the density is they are talking here right, density are going to be increasing and x times that of the brass replaces the brass bob, and its length is changed so that the period becomes 2t. Now this time period is given as 2t, it's given when you are replacing, so density becomes as 2t is given. Now here, so that the new length they are asking, what is the length of this one they are asking, L dash value they are asking. So here time period of simple pendulum formula will be t equals 2 pi into root over L by z. So time period depends only on the length of the pendulum, so that you can take as root L, you can take, it's independent of the density here, right? So t is directly proportional to L in the sense here you can get it as t1 by t2, which will be equal to root over L1 by L2, you can take. Initial time period let us take as t, then when you are replacing this one with the brass bob, here it becomes time period will be 2t. Initial length, suppose if I am taking as L, and here you just calculate this is L2 value, you just calculate. Tt gets cancelled, you just square on both sides. Here it becomes here 1 by 4. 1 by 4, which will be equal to, here will be getting as L by L2 will be getting. That doesn't mean here L2 final length will be 4 times of the initial length will be getting. So 4L is the correct answer. Let us take the next question. A man measures the time period of the simple pendulum inside the stationary lift and finds t seconds. If the lift accelerates upwards with an acceleration g by 4, then the time period they are asking. So here man is measuring here inside the stationary lift. This time period he has given as inside the stationary lift when it's making oscillations at the rest position. Here simple pendulum is making oscillations, then he calculated the time period value as t equals 2 pi into root over L by c. Whereas in the next case, if the lift accelerating upwards, this is a lift you can take. Now the lift is going to be accelerating upwards with some acceleration. That acceleration is given as g by 4, it's given. Now again here you are observing this simple pendulum oscillations. When the lift is accelerating upwards in this sense, the new time period value t equals 2 pi into root over L by g plus a will be getting. If the lift accelerates upwards, now here this is the value will be getting as g plus a will be getting. Now here you can calculate this value as t dash equals to 2 pi into root over L by, here this is if the lift accelerate upwards with an acceleration g by 4. Now here you just substitute this value, here we will be getting as L by g plus a, in the sense here we will be getting as g by 4 will be getting. Now when you are simplifying this one, t dash equals to 2 pi into root over this is L by, here we will be getting as 5g by 4 will be getting. So you just bring into the numerator. Now t dash equals here this is root 4 is nothing but 2 will be getting, and root 5 also you can take outside, which is nothing but 2 pi into root over L by g. The new time period value will be getting as t dash equals to here will be getting as 2 by root 5 into will be getting this is nothing but the initial time period you can take. So here 2t by root 5 is the correct answer. Let us see the next case here. The time period of the simple pendulum of length L is measured and an elevator. It's a descending with an acceleration g by 3. So initially here, right, simple pendulum inside the lift when it is at rest. So here it's a time period of oscillation, it is given as t equals will be getting as 2 pi into root over L by g. Now here the lift is descends down. Lift is going to be descending down with an acceleration a equal to is given as g by 3. Then here we just calculate the new time period value 2 pi into will be getting as root over L by g dash, in the sense here effective g value will be getting as g minus a will be getting. Then the new time period value 2 pi into will be getting as root over L by g minus a is nothing but g by 3 will be getting, which is nothing but t dash equals to 2 pi into will be getting as root over L by 3g minus g will be getting as 2g by 3 will be getting. The new time period value will be 2 pi into here this is root 3 by 2 will be getting 2 pi into this is root 3l by 2g. This is the correct answer. Let us see the next question. The next question says here, if the length of the simple pendulum is given as increases by 44%. Initial time period you are taking as initial length of the pendulum, suppose here if you are taking as L1, suppose you are taking as here 100 you are taking, L2 it becomes here 44% is increasing, then it becomes as 144. Then what is the change in time period of the pendulum they are asking. So here time period of the pendulum formula will be 2 pi into, you can take as root over L by G. Then here T is directly proportional to root L will be getting. Then here you can take as T2 by T1 which will be equal to, you can take as L2 by L1. Now here L2 it becomes as here 144%, and here initial percentage we are just considering as 100%. I just square on this side. So this is 12 or 144 by 10 you can take, 2 6 0 2 5 0 will be getting. Then T2 is nothing but here will be getting as 6 by 5 is nothing but 1.2 times of T1 you are getting. Then they are asking percentage increase in the time period, right? Percentage change in the time period is percentage change in the time period which will be equivalent to, here you can take as T2 minus T1 by T1 into 100 you can take, which is nothing but here will be getting as 1.2 T1 minus T1 by T1 into 100. This is 0.2 T1 by T1, 0.2 into 100 will be getting as 20% you are getting. So 20% is the correct answer. Let us see the next question. Here what is the velocity of the bob of a simple pendulum at its mean position if it is able to rise to a vertical height of 10 centimeter? If the bob is going to be rising to a vertical height, this is the height if you are taking. So this is the height and this will be the length of the pendulum you are taking, and this is nothing but here will be getting as L minus H will be getting from here to here. Now here you just take here with what is the velocity of the bob of the simple pendulum at its mean position if it is able to rise to the vertical height H. So after reaching some vertical height you just apply the conservation of energy principle according to law of conservation of energy principle. So here its kinetic energy has been converted into half mv square, which has been converted into it able to write some vertical height, in the sense its kinetic energy, right, it has been converted into potential energy will be getting at certain height. Here you can take, there are different scenarios will be getting here, different ways we can solve this problem. I am just using the conservation of energy principle, which is the simple technique. V equal to, here you can take as square root of 2gh you can take. It's nothing but V equals to 2 into G value will be getting as 9.8. Height is given as 10 centimeter, which is nothing but 0.1 meter you can take. So then velocity of the bob will be getting as at the mean position it will be, so nearly this is 1.4 meter per second will be getting. Let us see the next question. The next question says the length of the simple pendulum is increases by 1%. Its time period they are asking. So percentage changes if the length of the pendulum is less than 5%, if changes it is happening. Then here time period formula generally will be getting as 2 pi into root over L by G. Then here we can take as time period is directly proportional to the length of the pendulum. Then here its time period will be changes by the asking. That means here for small changes we can take as delta t by t into 100, which you can write it as L power 1 by 2 also. 1 by 2 into, you can write it as delta L by L into 100, you can write. In the question already this percentage is given. This percentage value is given as, here it is 1% is given. So here we will be getting as change in time period also. Here it will be getting as 1 by 2 is nothing but 0.5% you are getting. Here length is directly proportional to the t. Here will be getting as plus value will be getting, so that increases by, you can write. It's an increases by 0.5% will be getting. Let us see the next question. If the length of the pendulum of the clock will be 0.2, increases by 0.2% due to the atmospheric temperature rise, then loss in time period of the clock per day they are asking. So here 0.2% changes it's given. So here you can take time period of the pendulum will be 2 pi into root over L by G, you can take. That means here t is directly proportional to root L, you can take. So here small changes in this sense, here you can take as delta t by t, which will be equal to, here you can take as L power 1 by 2, and here you can write as 1 by 2 into, you can write it as delta L by L. But here they are asking here, then the loss in time clock per day it's given, right? 1 day carries here, so it's nearly 86,400 seconds will be getting. Time always you can measure in seconds. That means the loss in time delta t by here, this is per day in the sense 86,400, which will be equal to 1 by 2 into length of the pendulum is increases by 0.2% is given. So here you can write as 0.2% means, here you can write as by 100 you can write. Here this 100 and 100 gets cancelled. Here this 2, it becomes 0.1 times. Here you will be getting as delta t value will be getting as nearly 86.864 into 0.1, which will be equal to 86.4 seconds we are getting. Let us see the next question. The next question says, a simple pendulum is suspended from the roof of a trolley which moves in a horizontal direction with an acceleration is given as a. Then the time period is given as t equal to 2 pi into root over L by G dash, then G dash is equal to. Here a trolley is going to be moving with an acceleration a. Here when you are suspending a simple pendulum, here for accelerated frame of references, here we can talk about the pseudo forces. Then here pseudo forces it's going to be acting here opposite to the motion of the acceleration. This is here, this side will be getting. Then here this is pseudo force causes the pseudo acceleration. Here it will be directed left side. Here you will be getting a z, it will be acting downwards. So the net g value here it is going to be acting, g effective it will be acting according to the parallelogram law of vectors, it will be acting along its diagonal. Now here the net g dash value they are asking, g effective which is nothing but here you can write as a square plus g square plus 2 into a into g into cos 90 according to the parallelogram law of vectors. Then here this value will be 0, then here we will be getting as a square plus g square is the effective g value will be getting, g effective value. Now here a simple pendulum is set up in a trolley which makes to the right with an acceleration a on a horizontal plane. Then the thread of the pendulum in the mean position makes an angle theta with the vertical. So here a trolley you are taking. Now a trolley is going to be moving with an acceleration is given. You are suspending a simple pendulum. Now here it's going to be due to the pseudo forces, here it's going to be acting. Pseudo force it causes an acceleration along this direction ma. Weight of this bob it's going to be acting downwards mg. The net g value is going to be acting this side. Now the question is given as the thread of the pendulum in the mean position makes an angle theta with the vertical. So now here it's making an angle theta with the vertical it's given. Then here they are asking here in forward direction or backward direction theta value they are asking. So tan theta which is nothing but will be getting as here you can write as y component is MA by x component will be getting as mg. So here the net force value, it's going to be making an angle theta with the vertical is given, that is theta. MA by mg will be getting, it's nothing but a by g will be getting. Then theta equals will be getting as tan inverse of here a by g will be getting. So here it's going to be making in backward direction will be getting. So theta with the vertical, here it's going to be making in this side, it's going to be acting. Here this is a tan theta equals to tan inverse of a by g in backward direction. Let us see the next case. Here the time period of the seconds pendulum is 2 seconds is given. A spherical bob which is empty from inside has a mass is given as 50 grams. This is now replaced by another solid bob of same radius but have the different mass is given as 100 grams. The new time period they are asking. So be remember students, here initially the time period of the seconds pendulum is given as 2 seconds is given. Time period of the simple pendulum formula will be t equals to 2 pi into root over L by g. It depends on the length of the pendulum and acceleration due to gravity. Here initially you are taking here a simple pendulum of the spherical bob which is empty from inside and its mass is given as 50 grams, and this is now you are going to be replacing with the another simple pendulum but the different mass is given as here it is 100 grams it's given. Then the new time period is given. Time period is independent of the mass of the bob. Be remember this one. So here the final time period also will be getting as 2 seconds will be getting. Then let us see the next question. The next question says the metallic bob of the simple pendulum has a relative density is given as rho is given. And the time period of the simple pendulum is t. If the metallic bob now you are immersing inside the water, then the new time period they are asking. Now initially when you are placing in the air medium simple pendulum, then the time period of the simple pendulum here when it's making certain oscillations, the time period formula will be getting as 2 pi into you can get it as root over L by g you can take. Now here a metallic bob relative density is given. Relative density of the metallic bob is density of the body by density of the liquid you can take as here water you can take. So relative density is given as rho is given, density of the bob by here you can take as 1 gram per cc. As density of the bob will be getting as rho gram per cc will be getting, and density of the water you can take as 1 gram per cc you can take. Now the same you are going to be immersing inside the liquid. So here this is the body when you are going to be immersing inside the liquid. Now you are observing the oscillations. The new time period which will be equal to here will be getting as t dash which will be equal to 2 pi into g will be affected, then new g in the sense here g into 1 minus density of the liquid by density of the body you can take. So t dash is nothing but 2 pi into root over L by g into 1 minus density of the liquid will be 1 and here density of the body as rho will be getting. When you are simplifying this one here will be getting as 2 pi into it's root over L by g into here this is rho minus 1 by rho, that's nothing but rho by here will be getting as rho minus 1 will be getting under root. So with this here we can calculate, then t dash equals to 2 pi into root over L by g is nothing but t you can take, and here it's rho by you can take as rho minus 1 you can take under root. This is a new time period value. Let us see the next question. A bob of simple pendulum executes simple harmonic motion in water with a period is given as t is given, while the period of oscillation of the bob is t naught in the air medium. Initially in the air medium a simple pendulum is making oscillations. The time period will be getting as 2 pi into will be getting as root over L by g. So in the water it is going to be making oscillations. The time period is given as t is given. So this in the air medium you can take. in water if you are taking, so that the time period is given as T is given, that's nothing but here 2 pi into, it's G will be affected, G into, here you can take as 1 minus density of the liquid by, here you can take as density of the body contact. So here neglecting the frictional force of the water and given the density of the bob is given as already 4 by 3 gram per cc. So T equals to 2 pi into, here we can take as root over L by G into 1 minus density of the liquid is 1 we can take, and density of the body is given as 4 by 3, and it's 4 by 3 when you are talking here 3 it will come to the numerator, and 4 minus 3 in this is 1 by 4, 4 it will come to the numerator, then here 2 pi into it's 4L by G will be getting. It's nothing but T equals to here root 4 is nothing but 2 will be getting 2 pi into you can take as root over L by G. So this value is given as already T naught is given. So T dash equals to here T equals to here will be getting as 2 T naught will be getting. Let us see the next case. Here there is a simple pendulum having from the ceiling of the lift. When the lift is stand still, the time period is given as T is given. So this is a lift you can take, and here lift is going to be standing, and here it's making certain oscillations. Then the here when it is at rest, time period of simple pendulum will be getting as 2 pi into root over L by G can take. So now here the time period of the pendulum is T. If the resultant acceleration becomes Z by 4, then the new time period of the pendulum. G is decreasing. G is decreasing in the sense here you can take as, alright. So now we just calculate the new time period they are asking. So here let us take here T is inversely proportional to G you can take. Then here T2 by T1 which will be equal to you can take as Z1 by G2 you can take. And here T2 by initial time period is given as T is given, G let us take as Z you can take, Z2 it becomes Z by 4 will be getting. So GG gets cancelled, T2 which will be equal to here will be getting as 2T will be getting. So it's nothing but 2, root 4 is nothing but 2 will be getting. Let us take the next question. Here the effective length of the simple pendulum is equal to the radius of the earth and the time period they are asking. So here this is the case, here we will be getting as here this is the earth you are taking, this is an earth you are taking, and here you are taking on simple pendulum, and here a simple pendulum here you are suspending, and now here it's making oscillations like this. That means here length if it is much greater than radius of the earth, this is the radius of the earth you can take, and here in this case here time period of the simple pendulum formula will be getting as 2 pi into, here one derivation will be there students for this formula. I am giving directly 1 by G into, you can get it as 1 by L plus here 1 by R. This is a formula if the length of the pendulum is much greater than the radius of the earth. Here this is a formula you will be getting. So which is nothing but T equals to 2 pi into here if the length of the effective length of the pendulum is equal to the radius of the earth. That means here 1 by G into, instead of length you have to substitute as radius, and it's nothing but 1 by R plus 1 by R you can get. Here in this case here length is equal to the radius of the earth is given. So here you can take the simple pendulum on the surface of the earth you are taking. So when you are simplifying this one, here T equals to 2 pi into, so it's G 1 by here G into, here will be getting as 2 by R. Then here we will be getting as R by 2G will be getting. This is the time period formula. Let us see the next case, next question. The next question says, a second pendulum is placed in a space laboratory orbiting around Earth at a height of h equal to 3r is given, where r is the radius of the earth and the new time period of the pendulum they are asking. In the space laboratory, be remember students, here space here in space in the sense here G effective value will be getting as 0 will be getting. Effective G value will be 0. Effective G will be 0 in the sense time period value T equals 2 pi into root over L by G effective, it's 1 by 0, it's nothing but here will be getting as infinity will be getting. Means here time period is infinity doesn't mean here. So pendulum is not going to be oscillated. Pendulum does not oscillate. Let us see the next question. The next question says the mass and diameter of the planet are twice that of the Earth is given. The period of the oscillation of the pendulum on this planet will be there asking. Means here let us talk about the mass and diameter of the planet twice that of the Earth. Here it getting this is the Earth you are taking. This is an Earth you are taking, and here a mass and right diameter will be double that of the Earth is given. This is the planet you can take. Here mass of the planet is twice that of the mass of the Earth is given, and diameter is directly proportional to the radius you can take here, which is nothing but radius of the planet will be 2 times that of the radius of the Earth you can take. Now here there is a relation between small g and capital G in the gravitation topic. Here g equal to will be getting a gm by r square will be getting. Now when you are comparing these values here, mass and as well as radius, so then g is directly proportional to here will be getting as m by r square you are getting. Then let us take here g on Earth to the g on planet, which will be equal to mass on Earth by here you can take as mass on planet into here you can take as radius of the planet square by here you can take as radius of the Earth square you can take. So here when you are comparing these values, mass of the Earth it will be me, mass of the planet is given as 2 times of mass of the Earth, radius of the planet is 2 times of the radius of the Earth, so 4 re square by here will be getting as re square. So re square gets cancelled, here it will gets cancelled, 2 times I will be getting. So g by gp value will be getting as here it is 2 by 1 will be getting. Now here we just calculate the time period of the oscillation of the pendulum. So time period of the oscillation here, what the formula here, t is inversely proportional to g will be getting. It's nothing but time period of the seconds pendulum will be on the planet they are asking. So here you can take it as t on Earth by time period of the pendulum on the planet, which will be equal to g on planet by here you can take it as z on Earth you can take, it will be under root. Time period of the pendulum on the Earth will be a seconds pendulum is given. Seconds pendulum time period will be 2 seconds by time period of the pendulum on the planet they are asking, which will be equal to, so gp by ge value will be getting as gp by ge is nothing but 2 times of gp will be getting. So here gp by here you can take as z is nothing but 2 times of gp you can take under root. This will get cancelled, then time period of the planet will be, so here will be getting as when you just cross multiply this one, here will be getting as 2 times of root 2 seconds will be getting. This is the time period of the pendulum on the planet. So let us see the next question, students. Here imagine a narrow tunnel between the 2 diametrically opposite points of the Earth. A particle of mass m is released in the tunnel. The time period of the oscillation they are asking. Here it is given as here like Earth you are taking. This is Earth you are taking. You are making a tunnel diametrically opposite directions. So here you are making a tunnel and you are releasing a body you are going to be releasing. Now here this is the position of the body if you are taking. The body is going to be reaching the point P you can take. At this point, suppose here you are taking, this is whole mass of the Earth. Now here at this point you just calculate the intensity of the gravitational field. So here this is about the distance x you can take from the center of the Earth you can take. From the center of the Earth it is located at a distance x you can take. So here imagine a narrow tunnel between the 2 diametrically opposite points of the Earth. A particle of mass m you are releasing. Mass m you are releasing in the tunnel. The time period of the oscillation. Now here the moment when it comes here, restoring force is going to be acting along this direction. Now here restoring force, before calculating you have to know intensity of the gravitational field formula will be, it's a force experienced by unit mass will be getting. Then here this force you will be calling as, it's a restoring force in this case. Then here restoring force here F, which will be equal to, you can write it as minus E into m you are taking. It is in opposite direction you will be getting to the displacement of the particle. Now intensity of the gravitational field at a point P, in the sense here E value will be taken as, then here you can take F equal to, you can write it as minus. So intensity of the gravitational field in a solid sphere, the formula will be getting as, for a given distance, gm into x by, this is r cube will be getting, into m will be taking. So this is here mass of the earth, you can take, capital M is the mass of the earth you are taking, and this is the mass of the particle you can take, mass of particle. Now when you are comparing this one with the general equation, right, that is F equal to here minus kx when you are taking, instead of k here will be taken as, this is gm into x by gm by into small m by, here will be getting as, this is r cube will be getting, here will be getting as r cube. Now just take the time period of the simple pendulum formula, t equals to 2 pi into root over m by k you are taking. So it's a 2 pi into here mass, here it is given as m by, here k in this gm into small m by, here r cube will be getting, r cube we just bring into the numerator. So here small m gets cancelled. Here in gravitation there is a relation between small g and capital G, that is g equal to gm by r square you are getting. So t equals to, here you can write as 2 pi into, this is here r cube by, here instead of gm you can write as g into r square you can take, one r square gets cancelled. Now the time period of the oscillation t equals to, you will be getting as 2 pi into, you will be getting as r by g you are getting. So this is the correct answer. Let us see the next question. A pendulum of length is given as 2 meter. It lifts at the point P. Now here you are lifting to the point P. When it reaches the point Q again, here when it is reaching the point Q, it's going to be losing 10% of its total energy due to the R resistance. The velocity at the point Q they are asking. Now here you just apply the law of conservation of energy principle. According to law of conservation of energy, here at the point P it will be having the potential energy. The moment when it is releasing, here the potential energy has been converted into the kinetic energy. Now here between the point P and Q you are taking here potential energy at the point P, which it has been converted into the kinetic energy at the point Q you can take. Potential energy at the point P, which is nothing but here it's going to be losing 10% of its total energy. Already it will be having potential energy at the point P, in the 10% is going to be losing. Remaining in the sense here we will be getting as 90% will be there. 90% of the potential energy, it has been converted into the kinetic energy at the point Q will be taken. That is half m v square. Always be remember, for the remaining energies only we can calculate. Here mm gets cancelled, here we will be getting as v square equal to, so 2 into here you can get it as this 0, 0, 1, 10, 10 gets cancelled. Now 9 by 10 in this is 0.9 you can take. G into h. G value you can take as 10 you can take into h. H is nothing but, it's nothing but pendulum length you can take. Here it's a vertical height you can take. It's a 2 meter it's given. So here this is 2 meter you can take. Now we can simplify this one here. 2 into 0.9, here it becomes 9, 290, 18, 18 to 0. 36 will be getting. So velocity here at the point Q will be getting as 6 meter per second will be getting. Right? This is the correct answer. Let us see the next question. The next question says here, the two simple pendulums have their lengths it's given as, there in the ratio it's given they are making oscillations, and their length is given as here 1.44 meter and 1.69 meters respectively. They start in the same phase from the mean position simultaneously. After again how many oscillations, the longer pendulum, they will be in the same phase again, they are asking. Here you are taking two pendulums. One is shorter pendulum, you just call. There is a shorter pendulum you can take. One more you can take as longer pendulum you can consider. There is a longer pendulum you have to consider, and this will be the length of the shorter pendulum LS you can take. And here a length of the larger pendulum you can take as LL you can take. Now here their length is given, how the length ratio is given, length values is given. Now here initially they are in the same phase, they are at the extreme position. Obviously here you will be getting as time period is directly proportional to the length of the pendulum. The one which will be having the more length, that will be taking the more time period. So here the larger pendulum, it will take more time than the shorter pendulum. Suppose here you just look at the students here. If the longer pendulum, it's going to be completing one oscillation. So by the time it's going to be completing one oscillation, and again right here again it will start to go to the next oscillation. Like suppose if it is completed n oscillations in the sense, here let us take an assumption as shorter pendulum is going to be completed n plus 1 oscillations. So when time you are comparing in the sense, again they will be in the same phase after n oscillations in the sense, n into time period of the right larger pendulum, which will be equal to, you can take as n plus 1 times of the time period of the shorter pendulum you can take, which is nothing but here time is directly proportional to root L you can take. So n into here instead of TL you can take as length of the larger pendulum, which will be equal to n plus 1 of, so time period of shorter pendulum means here length of the shorter pendulum you have to consider. Now when you are comparing this one here, you will be getting as, this is n by n plus 1 when you are talking here, which will be equal to root over LS by root LL you can take. Then here it's nothing but here length of the shorter pendulum, it's given as 1.44. It's a 1.44. It's a 1.44 by here you can take as 1. Here you can take as 69 you can take. So it is 12 there will be getting 1.2 will be getting, here you can take as 1.2 by, it's a 1.3 will be getting under root. So here this is 1.2 whole square by, here you can take as 1.3 whole square you can take, square root gets cancelled. Here you will be getting as n by n plus 1, which will be equal to, will be getting as 12 by 13 will be getting. N it gives the length of the n is the number of oscillations made by the larger pendulum, n plus 1 is the number of oscillations made by the shorter pendulum you will be getting. Means here longer pendulum they are asking, longer pendulum they will be in the phase of 12 oscillations will be getting, and shorter pendulum if they will ask means here you can take as 13 oscillations you can take. There is the answer. Let us see the next question. A simple pendulum of mass is given as m is given, it's execute the SHM with the total energy is given as E if at an instant it is at one of the extreme positions. So here a mass m is executing a simple harmonic motion, and if the body is at the extreme position is given, then its linear momentum after a phase shift of 5/3 radians will be. So simple pendulum here it's making the SHM. Now here initially when it is at the extreme position it's given. After pi/3 they are asking the linear momentum. So displacement of the particle at the extreme position you can write as A cos omega t. So omega in the sense here it's omega t, or you can write as this is theta is given, right? Displacement of the particle after at a phase of pi/3. So here it's given as A cos pi/3 you can take, instead of omega t you can take as theta. It's given as A into cos, right? This is pi/3 you can take, cos 60 will be getting as 1/2, so you can take as A/2. Now here linear momentum they are asking, kinetic energy of the particle. Suppose here after the phase here, this is a displacement you can take as y you can take. At this point phase is given as pi by 3 radians is given. Kinetic energy at that point here we can write as half m omega square into you can write as a square minus y square you can take, which will be equivalent to half m omega square into a square minus, instead of y you just take the value a by 2, a square by 4 you are getting. Then kinetic energy you will be getting as here 4a square minus a square is 3 by 4 you will be getting. 3 by 4 of here you will be getting as this is half m omega square a square you will be getting. Half m omega square a square is nothing but here we will be getting as total energy of the simple harmonic motion. So here we will be getting as kinetic energy will be getting as 3 by 4 you are getting. Now they are asking the linear momentum at that point. You know the linear momentum and kinetic energy relation, k equal to here we will be getting as p square by 2m, and from this p equal to here we will be taking as 2m into kinetic energy you can take under root, which is nothing but 2m into kinetic energy is 3 by 4 into E we got. So 2 times it goes here you will be getting as 3 by 2 into m into E will be getting. So this is the correct answer for the linear momentum. 3me by 2. Let us see the next question. The period of the oscillation of simple pendulum of length L is suspended from the roof of a vehicle which moves without friction down on an inclined plane of inclination 60 degrees is given. So time period of the oscillation they are asking here, the moment when the body is going to be moving down on an inclined plane. Here I just take about this is the weight of the body here, it is going to be acting downwards, and here this is here when you are resolving here, this is here we will be getting a 60 degrees will be getting g. When you are resolving, this will be g cos 60 degrees will be getting, and this will be g sin 60 degrees will be getting. And here this is a pseudo force, here it's going to be acting here along this direction, g sin 60 degrees. Now here this angle it will be 60 degrees when you are getting here, this one will be getting as angle between g and as well as here angle between g and g sin theta. This is value here will be getting as 90 plus 60 will be getting 90 plus 60. So here for this case here you can take g effective value we need to calculate. G effective when you are calculating here between g and as well as g sin theta. G effective here which will be equal to this is nothing but here we will be getting a g square plus this is here we will be getting a g square sin square 60, or else I am giving the common formula students here. Suppose here you are taking this is g sin theta, suppose let us take an assumption, and this is g you are taking, and this will be g sin theta suppose you are taking, and here the angle between this one here if you are taking as instead of 60 here if you are taking as theta, and this will be the 90 plus theta suppose you are taking, and g effective value when you are calculating here you can take as g square plus, and here we will be getting a g square sin square theta plus, so 2 into 147 vector will be g and second vector will be g sin theta into you can take as cos of here will be getting as 90 plus theta will be getting. So from the parallelogram of vectors I am just taking here a net force value R equal to or R resultant force which will be equal to P square plus Q square plus 2 into P into Q into cos theta I am taking. So one force it's a G, another force is G sin theta you are taking, and here you are taking angle between the two vectors will be g and g sin theta will be 90 plus theta you can take. G effective when you are talking here you can take as g square plus g square sin square theta, cos 90 plus theta will be minus sin theta into 2g square sin theta, which you can write it as minus 2g square sin square theta you can take. So when you are simplifying this one, g square minus g square sin square theta will be getting, and here when you are simplifying this one, g into 1 minus sin square theta you can take, and then G effective value will be getting as G into 1 minus sin square theta is cos square theta, square and root gets cancelled, G cos theta will be getting. Then here when the vehicle is going to be moving down, then time period, new time period will be 2 pi into will be getting as root over L by G effective. Instead of G effective you can write as 2 pi into root over L by G cos theta you can write. That means here 2 pi into root over length of the pendulum is L, G into cos 60, theta value is given as 60 degrees you have to take, cos 60 value will be getting as 1 by 2 will be getting, which is nothing but 2 pi into, here we can write as 2L by G you can write. So this is the correct answer. Let us see the next question. The next question says here, a simple pendulum with the bob of mass is given as M and it oscillates from A to C. It's going to be oscillating from A to C and back to A such that PV is at a height is given as H is given. If the acceleration due to gravity is G, then the velocity of the bob as it passes through the B point you can take. Now here at the point B generally will be getting as, here it will be having more kinetic energy in a simple harmonic oscillation. So when you are applying here a conservation of energy principle according to law of conservation of energy, so here the potential energy, change in potential energy has been converted into the change in kinetic energy you can take, or potential energy at the point A you can take, which has been converted into the potential energy at the point B you can take. Potential energy at the point A when you are taking, here you can take, or else here B point you can take. Potential energy at the point A is nothing but it's a M G H you can take, which is at a height you can take, H you can take, and kinetic energy in the sense here at the point B you can take as half mv square you can take, mm gets cancelled, then V equal to, here will be getting a square root of 2 into G into H you can get. So this is a velocity at the point B will be getting. Let us see the next question. So the next question says here, a bob of simple pendulum of length is given as L is pulled aside from its equilibrium position through an angle theta, and you are releasing. The bob will then passes through the equilibrium position with a speed V, then velocity they are asking. Now here you are taking a simple pendulum, you are taking of length is given as capital like L is given. This is the length of the pendulum you can take, and now you are pulling aside and you are releasing. Now you are pulling aside here, which is making an angle theta with the vertical, and you are releasing. Now this is a vertical height which is raised by the pendulum you can take. This is H I am going to be giving, and here length of the pendulum is not going to be changing. This is L itself only. Now here you can say here H is nothing but how we can calculate in the sense. So this is total length is L in the sense here this length here will be getting as L minus H will be getting. So cos theta from this triangle when you are talking, so here let us take it as ABC is the triangle. So here from triangle ABC, so cos theta is nothing but adjacent side by, adjacent side is L minus H by hypotenuse you can take as L you can take. Then here with this here you can take as cos theta, which will be equal to, take LCM 1 minus H by L, then H by L equals to you can take as 1 minus cos theta, which is nothing but H equals to will be getting as L into 1 minus cos theta you can take. Now you can apply the conservation of energy principle from the law of conservation of energy principle. What they are asking here, velocity they are asking, right? It's equilibrium position with a speed V, then V is equal to, again the moment when it come back here, with what velocity it's going to be moving. So here at this point in the sense here potential energy has been converted into, so here at the point C, potential energy at the point C, it has been converted into kinetic energy will be getting, that is half mv square you can take. So here we calculated already here m into g into h is nothing but will be getting as L into 1 minus cos theta, which will be equal to you can take as half m v square you can take. Mm gets cancelled, then V maximum will be getting at the mean position. So here we will be getting as 2GL into, you can get it as 1 minus cos theta, you can take under root, you can take. This is the maximum velocity of the particle at the equilibrium position. Let us see the next question. A pendulum of bob has a period of 3 meter per second at its lowest position. At the lowest position is given as 3 meter per second and 0.5 meter long is given. The speed of the bob when the length makes an angle 60 degrees to the vertical. The same scenario here in the previous case. Speed of the bob they are asking here. You can take directly here a velocity at the mean position, in the sense here a speed is given as, here it is 3 meter per second at the mean position. Length of the pendulum is given as 0.5. When the length makes an angle 60 degrees they are asking. So here a length, if it is making an angle 60 degrees, there they are asking the speed of the pendulum they are asking, speed of the bob they are asking. Let us take here, this is a simple pendulum I am just taking. Now here you are moving the body which is making an angle 60 degrees to the vertical. Let us take this is the point A you can take and this is the point B you can take, and here this is the vertical height which is rising, and H already you know here H is nothing but this is length of the pendulum will not changes, and here we will be getting at this is L cos theta will be getting, this portion up to here will be getting as L cos theta, and here this one you can get it as L into 1 minus cos theta will be getting. H already we calculated in the previous question. H equals here L into 1 minus cos theta is the vertical height. This is the total length of the pendulum you can take. Then here to here we will be getting as L into 1 minus cos theta. Now here you can apply the law of conservation of energy. Here at the point A it's given as 3 meter per second is given. Now here according to law of conservation of energy you can take, or else here you can take conservation of energy. Here at the point A, total energy at the point A which will be equal to, here you can take as total energy at the point B you can take. Total mechanical energy is nothing but potential energy and kinetic energy will be getting. At the point A, at the equilibrium position you will be having only kinetic energy. So here kinetic energy at the point A plus potential energy at the point A which will be equal to kinetic energy at the point B plus, here you can take as potential energy at the point B you can take. At the point A, kinetic energy will be half mv square plus potential energy value will be 0. Kinetic energy at the point B will be getting as half mv square. So the V at the point B you can take plus potential energy at the point B, in the sense mgh will be getting. H is nothing but I am taking directly L into 1 minus cos theta will be getting. Now here let us calculate half into mass. It is given as mass you just cancel on both sides. At the point A it's given as velocity is given as 3 meter per second which is 9, which will be equal to half into Vb square we don't know, we need to calculate, plus G value you can take as 10 you can take. Here length of the pendulum is given as 0.5 into you can take as 1 minus cos 60 will be getting as 1 by 2 will be getting. Now just simplify this one. Here 9 by 2 which will be equal to half Vb square plus this is 10 into 0.5 will be 5 will be getting into here will be getting as 1 by 2. So when you are bringing this side, 9 by 2 minus 5 by 2 which will be equal to half Vb square will be getting. This is 4 by 2, 2 will be getting, 2 2s are 4 will be getting, Vb square equal to 4. Then Vb value will be getting as 2 meter per second will be getting. So 2 meter per second is the correct answer. Let us see the next question. The next question says here, length of the pendulum is given as L and its maximum angular displacement is theta, then its maximum kinetic energy they are asking. So here length of the simple pendulum is L is given. This is the length of the simple pendulum. You can take as L, you can take, and here maximum angular displacement is given as theta is given. This is theta is given, then its maximum kinetic energy they are asking. Suppose this is going to be rising at a maximum angular displacement, h height it is rising. H equals, you know the formula, we have seen already in the previous cases, L into, you can get it as 1 minus cos theta will be getting. So then its maximum kinetic energy in the sense here, according to the conservation of energy principle, at the mean position here, right, kinetic energy at the mean position here you can take according to law of conservation of energy. So kinetic energy at the mean position, which will be equal to here potential energy at the displaced position, you can take potential energy at a displaced position or at a certain height you can take. There are its maximum kinetic energy which will be equivalent to the potential energy at certain height. At a certain height, in the sense that's a maximum kinetic energy which will be equivalent to the potential energy at certain height you can take. That's nothing but we'll be getting as mgh. H already you know, mg into h in the sense L into 1 minus cos theta you can take. So maximum kinetic energy is mgl into 1 minus cos theta is the correct answer.